this video, we're going to look at change in velocity in a more complex form. So here we've got a pool ball which hits the cushion at 3 meters per second at 28 degrees to the cushion. It rebounds at the same speed and at the same angle, and we're going to calculate what the change in velocity is. Okay, so let's basically write down our solution. Now the first thing that we've got to do, and I always find useful, is to make sure you write down exactly what's happening. So here's our cushion, here's my initial speed coming in, and my final velocity leaving. So we know it's 28 degrees at both sides. We know that u is going to be 3 meters per second and v is going to be 3 meters per second. Now the change in velocity is going to be directly opposite, and the change in velocity will be caused by the cushion. So we know that the change in velocity basically can cause a change in the speed, and it can also cause a change in direction, but not always the same. Remember, velocity is a vector. Okay, so we know that delta v equals v minus u. So let's put all this together in a triangle. So here's my v at 3 meters per second, and here's negative u, also at 3 meters per second. Now the line joined up is delta v. Now if I put a perpendicular line here, I've got two right angled triangles. Well, I also know that they're going at 28 degrees from the cushion, and I've got this unknown value which is x. Now that's 90 minus 28, which is 62 degrees. So I know my angle inside the triangle. So basically I can split delta v up into two sections. They're going to be equally the same. So we're going to have x and x1. Actually we'll call x1 and x2. We add those two together, that will give us delta v. So if I can find one of the x's, the result will be I can basically work out what delta v is. Alright, so let's look at the angle. So we know that cos theta will always equal the adjacent over the hypotenuse. Now the angle here is going to be x, so it's 62. I know that the adjacent is going to be x1, and I know that the hypotenuse is 3. So rearranging, I can find that x1 basically is going to come out at approximately 1.4 meters per second. Now obviously to find delta v, I've got to double this value. So add them and multiply them by 2, and I get 22.8 meters per second. This is going to be acting approximately to the right, so we're virtually exactly the same. Okay, I hope that makes sense. Thanks for watching.